In this lesson, we're going to look at certain properties of the centroid. And remember, the centroid is the intersection of the three medians of a triangle. So when you look at this image, I have all three, I have the centroid and I have all three medians. And this is always true. A centroid splits the medians of a triangle into two smaller segments, and the segments are always in a 2-to-1 ratio. So if you look at DC and EB and GA, the longer segment is always on the vertex side. So if you look at that, and here's AF, and here's BF. The longer segment is always on the vertex side, and the shorter segment's on the other side, so on the midpoint side. So we're going to label the lengths of DF, GF, and EF, the smaller segments, as X, Y, and Z. So DF is X, if I can do that, and GF is Y, and EF is Z. So then we're going to find the lengths of CF, BF, and AF. Well, if DF is X, CF is going to be twice that. So CF is going to be 2X. And in the same way, AF, or let's see, BF is going to be 2Z, and AF is going to be 2Y. So that's how we set these up. And we have BF. So one side is always double the other side. In the next example, we're going to put some numbers to our line segments here. If DF is 4, so if this part is 4, CF is going to be double that. So CF has to be 8. The next one, BF, is 16, so let's take a look at BF. BF is 16, he's the doubled part, EF is the shorter part, so if BF is 16, EF has to be 8. And then finally, if GF is 10, that's the shorter part, so this has to be double, AF is 20. So you just have to remember, one is double the other. And then we'll take a look at the next example here. In the figure, we have the same figure, or a similar figure. EF is x plus 3, and BF is 5x minus 9. So let's take a look at that. EF is x plus 3, and BF is 5x minus 9. Well, you have to think to yourself, this isn't x and 2x anymore. It's not that kind of setup. You have to be careful with this, because which one's larger, EF or BF? And if you look, BF is the larger one. So BF is twice EF. That's what you have to remember. So I'm not going to double the BF side. I have to double the shorter side to get them to equal one another. That means I have to place a 2 in parentheses, and for EF, EF is x plus 3, and then BF is 5x minus 9. And we want to go back and substitute in and find the value of EF. So first we have to find the value of x. 2x plus 6 is equal to 5x minus 9. If I add 9 to the other side, I get 15. If I subtract 2x, I get 3x. So I end up with x being 5. However, I've got to find the length of EF. EF is x plus 3. So it's going to be 5 plus 3, and EF is equal to 8. Sometimes we're given the full length and we need to work backwards to find the segments. So in this example, we have DC is 15, and I need to break that up into a 2-to-1 ratio. Remember, if one side is x and the other side is 2x, that means they're all going to add up to 3x. So the total is equal to 3x. So that means 3x is equal to 15. So one part of that is 5, and 2 parts is going to be 10. If we look, DF is the single part, and CF is the double. So DF is 5, and CF is 10. So now that we have medians, we can use them in medians and altitudes in triangle proofs, which is what we're going to do next. So now we're going to look at how medians and altitudes are used in proofs. Here we have a triangle, and we're given that BD is the median of triangle ABC. So here's how we use it. We're given that, and then my next statement is going to say D is the midpoint of AC. And that's because medians are drawn to the midpoint. So there's my reason. What we write, medians are drawn to the midpoint. And I know these boxes, there's not a lot of room to write in these boxes. I'll have to make them bigger at some point. So once I say that D is the midpoint, then you have a congruence. You can say that AD is congruent to CD. And that's because a midpoint divides a segment in half. I'm going to write it down here. A midpoint divides a segment in half. Oh my goodness, I can't even write. Okay, a midpoint divides a segment in half. So if you are given a median, then you can say it's drawn to the midpoint, and then you can have a congruent statement because a midpoint divides a segment in half. Now the altitude takes an extra step. So what you can say from an altitude, and here's the altitude, is you can have a perpendicular statement. BD is perpendicular to AC. So after you're given the altitude, you say BD is perpendicular to AC. And that's because an altitude is drawn perpendicular. Or you can say the definition of an altitude. Altitude is drawn perpendicular to the opposite side. Okay? If we're looking for a congruent statement, then we can say, we could really say it in one and say that angle, you can say that these are right angles if you want to use HL, or you can say that angle BDA is congruent to angle BDC. Perpendicular lines form right angles, and right angles are congruent. So it depends on what you want to do with this. If you are looking for HL, then you would go with the from altitude to perpendicular lines to the fact that these are right angles and then that they are right triangles. So it really depends on what you're trying to accomplish. So you can either do it in 2 steps with perpendicular lines and then congruent angles, or 3 to get to right triangles. So let's look at this proof. Now we can use median, the definition of median and the definition of an altitude to get some more congruent statements. So BD is the median of triangle ABC, and I'm also given that BD is perpendicular to AC. So I don't even have, I mean, I could call it the altitude, but I don't need to. I want to prove that angle A is congruent to angle C. Well, the standard way we do that is we get triangles congruent, and then we can go back and get the corresponding parts congruent with CPCTC. So we'll start off by writing our given. So we have all that written down. BD is the median of triangle ABC. BD is perpendicular to AC. That's all of our given. So let's look at this. Let's start off with getting something easy. BD is going to be congruent to BD. Everybody can get that, I think. BD is congruent to BD, and that is the reflexive property. So there's reflexive. Okay, now let's use what we did for a median. We're going to say that D is the midpoint. The midpoint of AC. And to use that, we can just say definition of a median, or a median is drawn to the midpoint. Either way is fine. Definition of median. Okay, now that we have a midpoint, we can say that AD is congruent to CD. because a midpoint creates two congruent segments, or a midpoint divides a segment in half. Midpoint divides a segment in half. So I've got that. I've got my other side. Now I'm just going to get these angles congruent, and then I'll have side, angle, side. So I already have perpendicular lines, which means I can jump right to my congruent statement. Angle BDA is congruent to angle BDC because perpendicular lines form right angles, and right angles are congruent. So there's my statement. Perpendicular lines form right angles, and right angles are congruent. That's enough to do my triangle congruence, which is I now have triangle BAD is congruent with triangle BCD, and that was side, angle, side. And finally, I can say that angle A is going to be congruent to angle C because of CPCTC. Angle A is congruent to angle C because corresponding parts of congruent triangles are congruent. And you could actually go back and say a lot of things. If angle A and angle C are congruent, that also means that BA is going to be congruent to BC, either by CTC, or angles or sides opposite congruent angles are congruent in a triangle. Either way, what does that tell you about triangle BAC? And what kind of triangle must it be? You can probably answer that when I ask you that in class tomorrow.